I 3D printed this trim piece for my friend's 2017 Porsche 911 Turbo S, and apparently it's gone viral. Over 7 million views on YouTube, more than 12 million across all platforms. Even Supercar Blondie and Yahoo Auto wrote an article about it, which is honestly still kind of wild to me. But that original video I made was only a short, only about 2 minutes long, and it showed the results, not the full story. This wasn't just a cool little video I threw together. This was a real problem solved with real tools that saved real money. Today, I want to slow it down, break down exactly how I did it, what worked, what didn't, and answer the biggest questions you guys had. If you enjoy this type of breakdown content where I push what's possible at home, make sure you're subscribed to the channel. That's how I know to keep making projects like this. So here's the situation. My friend owns a 2017 Porsche 911 Turbo S. One day, he noticed one of the rear quarter panel air trim ducts was just missing, completely gone. We still don't really know if it flew off while he was driving or if somebody took it. You guys can drop your theories down below. Naturally, we looked up the replacement part, but Porsche wanted nearly $2,000 for a plastic air duct. It wasn't carbon fiber, and it's not some complex mechanical assembly. It's just an injection molded plastic trim piece. I mean, this thing could only cost maybe, I don't know, 20 bucks to make. If this exact part lived on a Honda, it would probably cost closer to 100 bucks, maybe even less. Now, I know what some of you are probably thinking.
If you own a Porsche, you should probably be able to afford it.
But that's not the point. The point is principle. A small injection molded plastic part should not cost $2,000. Whether it's Lamborghini, Porsche, Maserati, it doesn't matter. And unfortunately, when I searched for used or even aftermarket options, there basically weren't any available. None were plastic. The carbon ones were either only overlays or thousands of dollars as well. There's something I noticed with luxury and supercar ownership. There's an invisible tax on parts, essentially like a badge tax. It's because manufacturers file design patents on a lot of their exterior components. That makes it extremely difficult for aftermarket companies to legally reproduce them. If someone copies the design and sells it, they're likely going to get a cease and desist letter, which is exactly why I'm not selling this part. It's only for my friend and maybe some parts for myself as well. The crazy thing is, years ago, if you ran into this problems, your options were limited. But today, not so much, because 3D printing has become dramatically more affordable. It's no longer some industrial-only technology that only big businesses or someone willing to shell out tens of thousands of dollars could get. Regular people now can own these machines. And more importantly, 3D scanning, which used to cost tens of thousands of dollars, is now entering consumer territory, which is something that I'm really excited about. The printer I used for this project is the Creality K2+. It's one of Creality's flagship enclosed printers and usually sells for around $1,200. They also offer plenty of capable machines for just a few $100s. So there's lots of options here, and these 3D printers are becoming so much more affordable for people that like to do this stuff at home. So that's super cool. You can see I have a smaller one here. This is my Chitty, but I prefer the Creality K2+ for a lot of other cooler things. But you can just see the size-wise, this is so much smaller. However, this could easily print this in here as well. Now, there is something to keep in mind. For making car parts specifically, it needs to be made from the proper material. I printed this in ASA filament. ASA is UV resistant, heat resistant, and far more suitable for outdoor use than standard PLA. The reason I'm using an enclosed printer is because it allows me to maintain temperature stability and also allow you to vent fumes safely outside. So because this is an enclosed chamber here and it prints some nasty plastic chemicals, you really want to exhaust those fumes out the window. So you can pretty much create or print your own exhaust that attaches to the back of the printer. And then you run some ducting like this. You attach it, clip it onto the back there, and then you can run it out the window using something like this. Super simple, super easy. Highly recommend you vent this out because it produces some pretty nasty chemicals that is really not good to be breathing in. I also have an open frame printer, the Creality SparkX i7, which is a phenomenal everyday household print, but it's not meant for engineering grade materials. This is the newest Creality open 3D printer here. The enclosed ones are better for printing things like ASA, ABS, engineering grade filaments, but this is only $399. You get its own CFS machine. You can fit 4 rolls of filament into here, which is so cool. It even has the ability to do multi-color filaments. So if you wanted to print some really cool, elaborate thing in different colors, you can use this too. But keep in mind, because it's an open chamber, you can't print ASA or more engineering grade car parts or things like that. You can print PETG, which is cool. But for the most part here, this is more of a hobbyist, entry-level beginner printer that I recommend too if you want to get into 3D printing. So if you plan to just do regular 3D printing, then there is absolutely no reason to spend your money on an enclosed printer. But if you plan on doing more difficult prints, I highly recommend an enclosed printer because not only does it do the basics, it allows you to print with even cooler materials. For scanning, I specifically use the Creality Otter. Creality also has a huge range of scanners depending on your needs, from entry-level options all the way up to higher-end prosumer units. When it comes to 3D scanners, there are a ton. As you can see, I currently have 4 right here, and this is just a couple that Creality offers. And then there's so many other brands, but this is the first one that I purchased, and reason being is because it's like right in the middle. It's not too expensive, and it's not too cheap. It runs about $600 to $800 depending on a sale. Aside from this one here, which is more of the higher end consumer scanners here, we then have this one, which is the Creality Ferret Pro. This runs about $300 to $400, and you can see it is very tiny. It is a consumer scanner. It is the beginner entry-level scanners. You are not scanning complex stuff like this. It almost looks like the Xbox Connect scanner that a lot of people talk about. I mean, look at the size difference. There's a lot more money put into this, and you can get a lot more technology and advanced scanning with this one compared to this one. I mean, it's night and day. Then, working your way up, you have the Sermon S1 right here. This one is twice the size of both, but also twice the price. You're looking at close to $2,000 for the scanner. Creality also has a Raptor. This one is a step up from that. Raptor might be $1,500 to $1,800. This is about $2,000 to $2,300 here. It has infrared, blue laser, and a lot of pretty cool technology built into this thing here. So much so that it even has a warning label for laser radiation. So you want to be careful and not stare directly into this thing here. So if you're trying to scan complex things and you need it to be perfect, you want to stick for more of the higher end scanners here because you can get like a 0.02 millimeter accuracy, which is nearly identical to what it is that you're trying to scan. Then a step up from this one is the Sermon P1. This is the newest, latest and greatest scanner from Creality. You can see it looks very similar to the S1 here in terms of, the infrared lighting and stuff like that. They all look very similar, which is really cool. But, we go from $2,300. This one is my newest one that I just got. This is $3,500. And if I had this one at the time when I was making the Porsche part, I could have scanned it and it would have been nearly perfect almost instantly. Reason being is it has these blue infrared lines. Same thing with the Sermon S1 here. And what that can do is it can scan the depth inside these clips here. You could get really, really, really good depth in here, which is awesome. That's honestly something that the Creality Otter struggles with, which you're going to have to do a lot more CAD work and fixing it up and cleaning it up in the software afterwards. But when it comes to like the Sermon P1 or S1, you could probably get it on your first try. Now, the difference between this and why this one is $2,300 and this is $3,200 to $3,500 is because this is an all-in-one system. You no longer need to have long cables. You no longer need to have a very expensive computer to plug it into. This, as you can see, has a built-in screen. It has Creality Scan software in here. You can do everything you want with this and no longer need a computer and a separate scanner here. Because if you take this and you put this with a laptop, you're talking upwards of $4,000 when you can just buy this and it's an all-in-one system. You're no longer tethered to a computer. It's completely portable and you can move this thing around. So definitely make sure to check out all of Creality scanners. And if you have any questions, you can also drop them in the comments and I'll try to answer as many of them as I can. What's even cooler, before I forget, is Creality gave me a coupon code, Hayden10, that gets you 10% off their scanners. So if you're already thinking about getting into this space, that's one of the better discounts out there right now. Now let's talk about what a 3D scanner actually does, because I've been getting a lot of these questions. At its core, a scanner captures captures the surface geometry of an object. It records depth data and converts it into a digital point cloud. But what separates cheap scanners from better ones is accuracy, tracking stability, and how well they handle difficult surfaces. A lot of people I read were commenting that you could get away with using your iPhone or even like an Xbox Connect, I believe, and while you could scan stuff, it is certainly not at the degree that you could with one of these Creality scanners. It is a night and day difference, especially when tolerances and clips actually matter. And also, if you want depth and scanning like recesses, an iPhone or an Xbox Connect, it's not going to do that. Because if it's just a little bit off, it's not going to fit. But here's the thing, even with a good scanner like my Creality Otter, it tends to struggle with deep recesses like behind the clips. But this can easily be fixed with a higher end system using blue laser technology with a single line like the Sermon P1. This thing would handle that like a champ, and it would be a lot faster to reproduce a part like this. But for the price at the time, it just made sense to use the Otter because it is more than capable of handling this job. Now, if you're going to try to replicate this or do something similar at home, prep work is critical. Shiny plastic, black plastic, or like reflective surfaces can throw off a scan completely. So for me, I used a light scanning spray to kind of dull the surface and added reference markers so the software could track the movement when I scanned around it. I also made sure my lighting was fairly consistent with like an overhead light. Believe it or not, most bad scans aren't caused by bad hardware. They're caused by rushing prep work, not using a good spray, or not using little markers. Now, quick tip for anyone that wants to try this, instead of expensive scanning spray like I used, I didn't know this at the time, you can use a dry shampoo. It works surprisingly well and costs a fraction of the price. Now, when it comes to the scanning process, it's a lot slower and more deliberate than people might think. You don't just kind of like wave the scanner randomly over it. You kind of move very steadily, overlap your passes. It's almost like you're painting or vacuuming at this point, and you kind of let the software track the geometry. The goal isn't about speed, it's about getting as much clean data as possible. And depending on your scanner, within a few minutes, you'll have a good usable digital model. But that's kind of just the beginning here. A raw scan isn't necessarily print ready. It's somewhat messy. You have to kind of clean noise, smooth the surfaces down, fill the holes, and kind of generate a proper mesh that you can then send to the 3D printer. So after I got my scan, that mesh gets imported into CAD or Blender or some sort of engineering software that's free, by the way. Blender is free. Same with Autodesk Fusion 360. And that's where you can refine it further, clean up the surfaces, smooth them out, or you can just print it. And that's pretty much the hardest part of the whole thing, especially recreating the mounting tabs and clips, because those areas kind of experience the most stress. I specifically struggled with the clip geometry, and for now, I just clean them up rather than like fully redesigning them from scratch. But eventually, I want to get to a point where I don't just clean it up. I can actually rebuild this in CAD software and kind of reinforce them entirely so that they might not bend or break. But believe it or not, even the OEM Porsche part, all the clips and little tabs broke off too. So it kind of tells you it's not just my 3D print job. It might even just be the material that they use because it's ASA and that's fairly brittle, especially over time. The cool part is once you're in CAD, you're not just copying the part. You can also improve it, kind of increase the wall thicknesses, reinforce weak points, adjust tolerances. You can even make it stronger than factory or even more aerodynamic, let's say. Anyways, before I printed it in ASA, I did do a couple test prints in PLA to verify the scale and fitment because there's absolutely no reason to waste expensive filament dialing in tolerances when you can use a cheaper one. Also, orientation matters a lot too. You can't print on thin air, so you need to add supports or kind of have a smart orientation to it so that you can reduce the supports. But when you do that, you also affect layer direction, which also affects strength. So there's a lot more thought that goes into here, but once you catch on to it like a language, it's fairly easy to understand. Also, ASA shrinks slightly as well as it cools, so you have to compensate for that by scaling the model accordingly. Pretty much every single 3D print filament has its own unique personality, different strengths, different tolerances, some shrink, some might even grow. So when it comes to filaments, you can buy filaments pretty cheap. As you can see, I have a ton back here, all different colors. It really is quite the variety. There's hundreds of different types of 3D printing filaments that you can choose from. And when it comes to printing certain filaments, you need to dry them. So I have a drying box right here. It does start to grow, but it's all relatively inexpensive for what it is as a hobby. And if you're trying to start a business with it, a lot of this stuff, this hardware kind of pays itself off very quickly here. But they even have PLAs in all different colors. And then you have engineering grade filaments, which are up here in this box that I'm running. And these are like, you got nylon and carbon fiber, all different styles here. You can see how this is shiny, this is glass filled, which is crazy. This is carbon fiber filled. And then you have nylon, which is an extremely strong plastic here. And this is essentially different types of filaments that you can 3D print with that are used in cars, that they use on a car level in auto manufacturing, which is super cool. To even able to 3D print this just for testing purposes, I thought this was pretty funny. Now, one issue I ran into is the brittleness of those small tabs. Because of the layer orientation, they were kind of weaker than I wanted it to be. If I do end up doing this again, I may dabble with some other filaments like nylon, because I believe it has better layer adhesion, which means it's not as brittle as ASA is. So I'm curious if printing this maybe in nylon or even ASA CF, or maybe angling the part on a side would improve the clip's strength. That's part of the learning curve here, but feel free to help me out down in the comments below. Now, after printing, the finishing process is basically traditional auto body work. I use generic sandpaper, then 320 grit, a Bondo one-step primer for like 20 bucks, and then I use Napa 2K automotive primer with a hardener in it. And then I had a body shop just use a black base coat and 2K clear, which if you're confident, this can easily be done at home as well. Now, once installed, it pretty much fit perfectly. Now, I'm not claiming this is a professional quality part by any means. I'm still learning as I go. And of course, there's still a lot I can improve on. But the bigger takeaway here is this. Look at how advanced at-home technology has become. It's truly fascinating. I feel like we're just scratching the surface, and it's only going to get even better. Now, let's talk numbers. The question all you guys keep asking me. When it came to the factory replacement Porsche trim, it was around $2,000 after tax. My cost was about $20 in ASA filament for the roll. The reason it's so cheap is because I already own the printer and I already own the scanner. Now, if you don't, a capable enclosed 3D printer might cost you maybe 500 bucks, and the scanner is around $600, maybe even cheaper if you use my discount code. Scanning spray is about $12 if you use my dry shampoo trick, and software can be free and open source, which is what I use. Then if you want to get into the nitty-gritty, electricity and time were pretty minimal, because while I was printing it, I was also doing other things, so we're not going to add that in as well. But here's the thing. You don't throw the 3D printer and the scanner away after you make one part. You continue to use them. You make more parts. You solve more problems. You can even make your money back faster than you think. This isn't about replacing manufacturers. It's entirely about having options, maybe even starting your own business or solving more problems. Just think about it for a minute. When parts go out of production, when prices become unreasonable, which I'm starting to think they are, and when companies stop supporting older vehicle parts, you're not stuck anymore. This isn't some distant future scenario. It's happening right this second. And once you use 3D scanning to solve a real world problem, you'll start seeing opportunities you can solve everywhere. The Porsche duct itself isn't what's revolutionary. What's revolutionary is realizing you don't need permission anymore to fix your own stuff. And that means everything to me. So guys, let me know what you think down in the comments below. And if you're interested in getting a 3D scanner yourself, check out the link and use the code Hayden10 for 10% off, because we're just getting started. Otherwise, if you haven't already, definitely make sure to smash that like button, turn on post notifications, subscribe, and I'll see you guys in the next episode. Peace.